Testing, can you hear me? Yeah. Well, hi, my name's Rupert Newman, and thank you very much for inviting me here. And thank you to the board for inviting me. It's my first time in Sweden, and what I've seen of it so far, I think it's a lovely country. It looks fantastic. I hope to see a lot more of it in the next couple of days. I'm going to talk to you about building frames in the UK. I've actually been building frames for 30 years now. And I have this little company called West Wind Oak Buildings. And we're based in the southwest of England, near the cities of Bath and Bristol. And we're out in the countryside. And this is actually an old chicken farm. You can see the remains of the ventilators and stuff like that. That is where our workshop is. And this is all my crew here, carpenters and office people, designer. So we're a mixed bunch, and a lot of them have been with me for many, many years. Yeah, so I suppose the timber framing revival started in America in the 70s. And at that time, I was a little boy in a village near my workshop. And all us kids had to get jobs on Saturdays. And my job I got was working for a local carpenter who was doing up his house. So every Saturday for 5 or 6 years, I'd go up to his house and he would get me sanding down windows and painting things and digging holes and moving concrete around. And, you know, I picked up the odd thing here or there, and it was a good sort of introduction to me. By the mid-'80s, the timber framing revival had come over to the UK. I think partly was because it started in America and there was literature available, but partly because there was a trend at the time for people doing up barns. People wanted to do up barns to turn into houses, barn conversions, and, you know, big open spaces. And people wanted that open space living. But, you know, the supply of barns were limited, and I suppose somebody thought, well, why don't we just build a new barn, like they've been doing in America? This is me around about the same time. I'd been at university and studied naval architecture. And when I left, I wanted to get a job designing yachts, but I couldn't find a proper job, so I fell back into the carpentry. You know, I'm looking very serious in those days. But we didn't really have much clue about what we were doing. And so I looked for inspiration. So I should go back to this slide a minute. I started just fixing windows when I left university. And then I hung doors. And then I fitted kitchens. And then one day somebody said, will you build me a roof, Rupert? And I didn't know how to do it, but you know, I studied mathematics at university, so I got my calculator out, and I worked out all the angles, and then I got all the wood, and cut it all, and a week later, I'd built them this roof. They were very happy with it, and they paid me well for it. And suddenly I started thinking, yes, building big is good. So I built loads of roofs after that, and then that led on to me repairing old roofs, and then I worked for a group called English Heritage, and they preserve ancient buildings in the UK, and I worked repairing medieval roofs. And so I learned a bit about medieval carpentry, and but one day I decided I wanted to build a new roof. I didn't have much idea how to do it, so I looked for inspiration. I discovered this book here. It's called Discovering Timber Frame Buildings. And this is my original copy here. And you can see how well thumbed it is. And I read this from cover to cover. And it was a fantastic inspiration to me. It's written by a guy called Richard Harris. And he was the creator of the Wilden Downland Open Air Museum. Now, this is a museum where they collect ancient buildings that are going to be knocked down because perhaps they're going to build a road or something like that. And they rebuild them in this museum, and you can go and see. The book here, you can see, is full of fantastic diagrams about how medieval buildings were put together. So I learnt a lot. Then I discovered this guy. Do you know who he is? I'm sure you do. This is Ted Benson. So I discovered his book, this one here, The Timber Frame Home. So this didn't only talk about building frames, it talked about how to finish buildings off. And that was really important to me because there wasn't any material on that available in the UK. And it, taught me how to put the roofs on, how to build floors, where to put the wiring and plumbing. And this is Ted a couple of years ago at one of our conventions. He's holding this very big mallet, and he looks like he's going to do somebody some serious damage with it. Then, in the early 90s, a group of carpenters got together and decided that we needed to share our knowledge on timber framing. So it started to produce this magazine. This magazine, the Mortises Tenon, was just typed out on A4 bits of paper, photocopied, and sold for €1 or the equivalent. And it was a fantastic publication. It had carpenters, historians, architects, engineers, all contributed to it. And it basically spread the knowledge of timber framing to the wider community. And I've got the Carpenters Fellowship produced this. Is the first 10 copies of the Mortises Tenon. And you can have a look at it. Look, Norway, land of laughing. What other examples? And so, talking about different types of joints. And hewing and all sorts of stuff. So this stuff wasn't known before now, and the knowledge of it spread, and soon more and more people got to know about how to actually build timber frames properly. It's a fantastic bit of trigonometry there, and hewing. So because of the magazine, we decided to form a guild. So in around about 1990, we formed the Carpenters Fellowship. So the Carpenters Fellowship, like your guild, to exchange knowledge, represent the oak framing industry, have a magazine, and produce qualifications. But we still needed inspiration, so I looked at inspiration from the buildings that were around us. This is a Wilden Hall house, and it's at that museum I talked about earlier, the Wilden Downland Museum, and it was built around 1405, and it would have been built for a wealthy landowner or farmer. You can tell this by the jettied floors and all the bracing and everything like that. And it's an amazing bit of design, because this is, back in 1400, somebody designed this. It's a hall house, so the centre of it is open up to the ceiling. You would have come in through this passageway here, and this end of the building was the service end. So you had the dairy and the pantry. So the dairy is where they kept liquids, and the pantry is where they kept food. And I suppose the servants would have lived above it. And then this would have been the lower hall, where the servants would have sat on benches. And this would have been the upper hall, where the high table was, and the master of the family would have slept. And of course, the open fire, so the whole place would have been full of smoke. And they would have tried to control the smoke by opening and shutting these doors here. And behind the high table, they would have had windows to shine light down on it. And behind this, there was a room downstairs called the parlour, where was a private sitting room. And above that, the solar, where there was a private bedroom for the master of the house. So I looked at buildings like this, and this is one that I built. So to start with, we sort of copied what was already there. And you can see, it's got the jettied floor and the passing braces and everything else. This is Westminster Hall, an amazing bit of carpentry. It was commissioned by Richard II in 1393, and it was constructed. We actually know the carpenter's name. So this carpenter would have designed this and built it. So it's an amazing craftsmanship. He was called Hugh Herland, and it was finished in 1401. What is amazing about this as well is it's a hammer beam construction, so it's got an 18-metre span. So that carpenter must have had some serious engineering knowledge as well. But in England, in the UK today, the buzzword in construction is off-site construction. Everybody's trying to move towards off-site construction because it's quicker, it's easier, it's more efficient. Well, this is off-site construction. This was made 60 miles away in a place called Farnham, and all 660 tons of it was transported to London on carts and barges. So, this is my interpretation of the hammer beam truss, and we're spanning it over a swimming pool, but it is fundamentally the same technique. This is at Cresting Temple. It's the barley barn at Cresting Temple, and it was built by the Knights Templar, and it was built as like a tithe barn. Now, a tithe is a tax. It's a tenth of all that you produced in a year. They would take it as a tax and store it in their barn, and then they would sell it and fund their crusades. It's supposed to be the oldest standing barn in the world. It was built in 1220. It is aisled construction, so it has an upper wall plate and a lower wall plate, and it has these arcade posts running down the middle, and then posts on the outside. And this was my interpretation of it, with the upper wall plate, the lower wall plate, and the posts running down the middle in a modern barn-style house. As the years have gone on, though, our designs have become more contemporary. People wanted less visible wood on show and just mainly the main structural elements. So you can see here, this is like a raised crux, so it's a very ancient form of construction. But, it looks quite contemporary in its setting, with the glass balconies and the light and everything else. So this tends to be more the style of building that we produce nowadays. And this is one stage further. It's got very minimal amounts of oak. It's got straight braces, and it's looking much more contemporary than those earlier projects. So I'll talk a bit about green oak, because that's our main thing that we use. To start with, it's called green oak not because it's coloured green, that some people think. It's green oak because it's freshly sawn oak, and it's not dried out. And green oak has been really important in the history of Europe for thousands of years because it's such an amazing product. It's durable, it's strong, but one of its most important features is it's easy to split. And because it's easy to split, it's easy to make into beams. So it was easy to be a useful timber to make buildings out of. And it's lovely to work as well. But the problem is with green oak, as I'm sure you're aware, is it shrinks. So, we're using the oak when it's got about 80% moisture content. And it's heavy, yeah. It's heavy, yeah, but we're strong in England. So I'll talk a bit about the process now. So what happens is, the phone rings and somebody will phone up and say, I'd like an oak frame building. And we'll say, have you got any designs? They say, oh, no. And we say, well, maybe you should go and find an architect or something like that and come back to us. Or have you got a site? So we get, mainly our clients are self-builders. So they're like people that want to build their own house. But they're not actually going to do it, even though they're called self-builders. And architects who are working for self-builders, or architects who are wanting to do a commercial type project, and occasionally from engineers as well. So we get an architectural drawing, something like this, sent to us. And as Andrew has said earlier, we then have to try and design a frame that will work structurally and work with the design. We do this on our software here, and then we will produce a drawing and give them a price. If they accept the price, then we go into a much more detailed design phase where we're coordinating with the architect until we finally sorted out the whole of the design issues. The next process of that is bringing in the engineer. So we have a thing called building regulations in the UK, and all our buildings have to be passed by a governmental organisation, and they require a set of calculations from an engineer. So we send our frame drawings off to the engineer, and then hopefully get the answer back that we want, which is don't change anything. But occasionally they will say, can you increase the size of this beam or that beam? Once that's all signed off, we can order the timber. Now that timber ordering process can take up to 6 or 8 weeks. So it's quite a long time from when we put the order in to when it's actually turning up in our workshop. But that's because each piece of timber is individually sawn for each job. So the computer generates a reference number, and that goes to the sawmill. The sawmill cuts the timber, and it has the same number when it comes back to our workshop. So that the carpenters know exactly where in the building that piece of timber is going to go. During this period, we produce these drawings for the carpenters. So the carpenters will take these drawings and they'll put their own marks on them. They'll scribble all over them. They'll say what size joint they're going to put here and what size joint they're going to do there. And blah, blah, blah. And this is actually one of the houses I'm making at the moment, which is inside my workshop. Now you can see the date down there, like 28th of March, 2018. So I want to talk a bit to you about making frames. We make each plane of the building full size in our workshop. So we make the cross-frame planes first, we make the wall frame planes, the roof planes, maybe the floor plane. And some timbers are common to more than one plane of the building. So this post here is common to the cross-frame plane, and it's common to the wall frame plane. So we call that a primary timber. And then all these other little timbers in here, we call secondary timbers. So the principal rafter here again is a primary timber because it's common to more than one plane of the building. So we're laying out frames full size. This is out in the yard. This is a small frame. But you can see they've sort of jointed the primary timbers together and they're laying on the secondary timber to mark them up. We do a thing called Scribe wall layout in our workshop. And primarily in England, that's what we do. This is a very, very complicated thing to explain. I could spend all week explaining it to you. So I'm going to try and give you a simplified version. But if anybody of you want to ask me about it later, I'll try and fill it in. We're using plumb bobs here. So we lay the frames out full size in the workshop. So they're all put on the second point. And we lay the timber on top of each other. Now, if you can imagine this timber on top dropping vertically and meeting perfectly the timber below it, and where they join, they fuse perfectly, so the two actually meet, where you can see this red here, that's what we're trying to achieve by scribing. And so we're mapping the surface of one timber onto another and vice versa. And once we've mapped it on there like that, we can then draw the joints on it, cut the joints, put it all together, and hopefully it fits perfectly. That's a simplified version. This is the level mark, which I'm going to explain about now. This is a level mark here. So you know I talked about primary timbers that are common to more than one plane in the building. When we make the cross-frame plane, for example, on one of the primary timbers, in the middle of it, we will make a level mark, and we will actually rock the timber until it's perfectly level. Because you have to remember, the timber of this size is not square and it's not straight. Even if they try to cut it, once it's cut, it will twist and bow and bend. So in the middle of the timber, it's marked perfectly level. So when it's made up in the first plane, that is perfectly level. When it's made up in the second plane, that is rotated till it's perfectly plumb. And we know that it's done a theoretical 90-degree rotation. It doesn't matter how square or twisted the timber is, because of that point in the middle has been marked on the level mark, we know that it's theoretically rotated 90 degrees. And so it means that when the building goes together in 3 dimensions, it fits perfectly. This mark is evident on many medieval buildings. So we know that that's the way that medieval carpenters would have made it as well. So we stack the timbers up, and you can see little wedges here. That's where they're wedging those primary timbers to make them level in the middle. And then they're scribing the joints, so they're transcribing the joints. And, this is Adge, and he's got a double stack going on. And then the joints are marked out. Once we've done the shoulder lines from the scribe, the joints are marked out. They're roughed out with handheld circular tools and cleaned up with chisels and planes. So we tend to do different layouts. So we start with one layout, which is the primary timbers, then we lay more timber on top and do the scribing process again, take the whole thing apart, cut the joints, put it all back together, then maybe do another layout, lay it up on top again. So this is inside my main workshop, and you see all the timbers everywhere stacked up.
Where do you have the join? Is that on the floor?
The join's there. Okay, so that's different way of, that's like lofting, where you actually draw the frame out full size on the floor. We don't do that. So you can see here, we have ink lines. So the top of the wall plate is marked and the bottom of the sole plate is marked. Then we ink a line, and it's usually 50 millimeters down. And then everything is set out from the ink lines. So it's placed on trestles, it's measured so all the ink lines are exactly the right distance apart. Then we lay the next set of timber on top. Okay, and yeah. So we get to this stage. This is a stage where, we've made it, taken it apart, put it back together again, taken it apart, put it back together again. And you can see they've got the tape here, and they're checking it for square. And, a frame like this, we would be working to maybe a few millimeters over the square. So over maybe 20 meters. That's how accurate they would be trying to make it. And you see they've got a string line running down there to make sure all the beams are running dead in line. Now, it's dead in line on the ink line that's on there, not on the top, because the timber could be going like this. And the final thing we do, we drill holes through the mortises, and when we haven't drilled the hole in the tenon, which is in this joint here, so we put it all together, we make it all square, then we mark the center of the hole through the mortise onto the tenon. And when we take it apart again, we drill that hole slightly offset. So when it goes together in the building, when it finally goes together, if you were to look through the mortise, you would see the two holes don't quite line up. And when we bash through our pegs to join it all together. It tries to force those two holes together, which makes the joint incredibly tight. And it keeps the joint tight even when the frame is shrinking. So this is Gabriel, my apprentice at the moment. And that is his job. His job is to make pegs. That's one of his jobs, to make pegs. And they come to me, and the first 3 weeks they make pegs, and their hands are raw, with blisters and stuff like that. The first thing he does is he takes blocks of oak, and they tend to be the offcuts, and splits them into squares like this. And then they stacks them up so that they dry out a bit, because we don't want the peg to be too green. We don't want it to be completely dry, but we want it to be drier than green oak. In fact, quite a lot drier than green oak. Then he bangs the peg through a die, and out pops peg, like this. So this is a 3/4 inch peg. It also makes inch pegs, which are 25 millimeters in your money. And then finally he uses an axe and puts a point on them so that when he bangs them through the frame, they can follow the two uneven holes. Otherwise, it would just hit a wall. This is a tapered peg. It's made by a slightly different way. We start off with the block again, but then we're using a thing called a draw knife. So this is actually shaped by hand. So I can pass these around.
How do you leave the pegs when you have assembled them?
So what we do is we bang them through, and we cut them off, leaving that much. Because the frame is going to shrink. So if you cut them off flush, they'd all end up sticking out a little bit. Whereas if you leave them sticking out to start with, then it doesn't matter that the frame shrinks, because they're still sticking out. In fact, people like it. And I've got an oak-framed extension, and those pegs are really handy for hanging coats on and stuff like that. So yeah, this is Gabriel in his world of banging out pegs. You can see Liddell down there. Oh yeah, this is a time-lapse of Sam, one of my carpenters, making a frame in the workshop. So he's getting the primary timbers together here, and he's cutting the joints of them. He's just done a mortise over there, chiseling it out. Then he's getting the primary timber together, squaring up. He's laying on the principal rafters. He's got his level there, on his level mark, laying on the braces. Then he's cutting the joints on the principal rafters. He's doing the mortises on the posts. Putting it all back together again, level mark again. Then he's laying on braces, on the secondary braces. He's laying them up here, scribing them, taking them off, cutting the joints on them. Then he's doing the mortises on the posts here and the mortises on the principal rafters. So he's doing the mortises there. And then he's going to do the peg holes there finally. Then putting it all back together for the final time, night time, bedtime. Then the next day, back again, checking it square, marking the peg holes. Taking it all apart, cleaning up like a good carpenter. They're looking at the drawings on the wall for the next frame. And this is the frame that he was actually making in the workshop there, actually in sight on the building. You can see all the pockets for the floor joists and stuff, and it's sort of oak rafters going on. And so finally, we mark the timbers. And we mark the timbers with carpenter's marks, and we know about carpenter's marks because we've all looked at ancient medieval buildings. And we have developed our own system of doing it, but basically we're using Roman numerals. This is 9, so it will be connected to cross frame 9 in the building, and it's straight 9. So we do straight chisel marks on one side, and we use a gouge to do curly chisel marks on the other side of the building. So this would be like curly 6, because this is actually a 5 and a 1. So simply what we would do is we would mark everything on one side of the building with a curly chisel mark and everything on the other side of the building with a straight chisel mark. So this would be curly 1, curly 1, curly 1, curly 1, curly 1, and then, if I straight 1, straight 1, straight 1, straight 1. And then the next cross frame would be 2, and then 3, and so on like that. And the beauty of it is we know when we've got a big pile of timber, and we can see where the mark is, we know where that's going in the building, we know which way round it's going, and which way up it's going. So, for instance, the posts are always marked at the top, the braces are always marked at the bottom, so we know exactly, we can map exactly where every piece of timber goes in the building. Finally, we get to this stage where it's all loaded onto a lorry, and off we go to site. So we're a specialist company. We basically just make the oak frame. We don't do any of the rest of the construction, really. So when we turn up on site, we normally have a slab like this and maybe some scaffolding. And we are raising our frames piece by piece with a crane. So this is different to in America. So in America, they evolved in building their frames in a different way to us. And also they tended to do more community raisings. So they tended to put more of the frame together on the ground, whole cross frames, or bents as they call them, and raise the whole frame. And I don't know if you've seen that film Witness with Harrison Ford about the Amish people. Well, that's a classic. That is the American way. Whereas in the UK, it tended to be just the few carpenters that made the frame that raised it. And that is carried on today. We do make the trusses together on the ground because it's easier and it's safer to put them in just as one piece. So here we go. This is one that I put up 6 weeks ago. And this is the top half of an arch braced truss. There it's going. There's the guys on site. You can see it's pretty cold weather. And there is the whole truss together. This cross frame's got 74 pegs in it. Right, so that's 1, 2, 3. There's over 220 pegs just in those 3 cross frames, which poor Gabriel's made all by hand. Yeah. So this building has got 2 wings of it. That took us about a day and a half to do on site, and it's going to be an ice cream restaurant. Bizarrely enough, this is on a beautiful farm in Devon, and they have cows and they make their own ice cream, and they get people stopping, and people will stop and go into their lovely oak frame building and buy ice cream. So, and finally, we have to bang the pegs in. The pegs that Gabriel so lovingly made. And it's actually quite a hard job because they're quite hard to bang in because the 2 holes don't line up. And if you hit it too hard, you'll snap the peg. And if you snap the peg, then you have to try and get the snapped end out. And so you don't actually snap pegs very often, not once you've started. You just,
So, do you use something on the peg, or not?
Okay, so traditionally, they use tallow. Do you know what tallow is? It's sheep fat. Okay? So when I was younger, we thought, we'll use some tallow to make it easier. But the thing is, it's like grease, and when you bang it in, it stains the wood. You get a stain that's actually inside the wood. So even once you've cleaned it, you've got this stain there. So we experimented with lots of things, but now we use silicone. Like tube of mastic silicone, the white clear stuff. You just put a tiny bit of that on, and you rub the peg around, you bang it through, and then when it dries, it will just peel off. But it makes it much slippier, so it makes a lot less chance of it snapping. So I've got a couple of little case studies here. So this is a bit like Westminster Hall. It's been transported by boat and then by lorry. This is at Brevik in Norway, and this is a house I built there a couple of years ago, and you can see all the oak on the back of the lorry there. And this is on site, and you know, we had the foundation there when we got there. I had built it for a Norwegian woman and an English man, and they sent me their plans over, Norwegian architectural plans, and I, you know, designed the frame from that, and then there was a period of adjustment, we came up with the final design. The client wanted it quite contemporary, so it's all straight braces and fairly minimal oak. So Ina, the Norwegian woman, she was very particular about what she wanted. And this is us putting on site. So we're up to the roof stage now. And you can see inside the building, we're also using the SIP panels that Andrea described before. So we designed the frame in 3 dimensions, and then on top of the same drawing, we designed the SIP panels. And the SIP panels are then sent off to a company called Kingspan, where they're cut on a big CNC machine, and they come to us in a kit form that perfectly fits the frame. And as you can see, we've put these battens on top of the timber, on the outside, everywhere.
What dimension?
Well, these ones are actually a 75 by 50 because they're having extra insulation inside because they're going for almost passive house standard. But normally we would use a 50 by 50. Well, it's actually 47 by 47 CLS size. So what we're doing here is we're putting a counterbatten on the outside of the oak frame. And this is the oak, green oak here. And we're fixing the SIP panel into the counterbatten. And then we put a smaller batten on the inside of the SIP panel. And then the plasterboard slides behind the back of the oak frame. And it leaves a little shadow gap there. And the reason we're doing this is because green oak shrinks. And we know it's going to shrink. So we design everything to allow for that shrinkage. So when this shrinks here, there's going to be no cracking of plaster. There's nothing that's going to change in the building. And
How much is that? 5 millimeters?
yeah, 3 millimeters, 5 millimeters. I mean, sometimes architects want it more. They want to see a bigger, in which case we have to then paint the side of the counterbattens black. You know, because if you have a bigger shadow gap, you could sort of almost see around the side and see the wood. And then the side of the counterbands are painted black. So there we are, the wall's going up, the SIP panel's going on. They've already got the holes and cut out for the doors and the windows. The doors and the windows are fixed directly into the SIP panel in this case. So there's no problem with shrinkage because the SIP panel's not going to shrink. Only the green oak frame's going to shrink. And then we're putting on the roof. And finally, it's covered with a breather membrane. And so it's completely watertight. So that is 1.5 weeks on site from start to like watertight building.
What did you cover it with? For water.
What is a breather membrane?
Okay. Right, so if you build a timber wall with insulation there, on the inside of it you should have a vapor barrier, and on the outside of it you should have a breather membrane.
But the SIPs are made out of foam.
Yeah, it's to do with the transfer of water vapor through the wall. Yes, it's a very technical thing, but you need to have a ratio of 5:1 between. Yeah, okay. So, and the breather membrane is also a waterproof membrane as well. So it makes the whole structure waterproof. Yeah. So this is it on the inside when it's finished now. Very sort of contemporary Scandinavian sort of feel to it. And upstairs as well, with a rocking horse, you know, and this is it out on the outside. And, you know, it's clad in wood, which is fairly typical around here. And the windows, are, like I say, are placed inside the SIP panels. They've got some visible oak on the outside as well, because they've got some balconies and stuff like that, which is fitted after the SIP panels have gone on, so it's right on the outside of the building, so there's no sort of water penetration or anything else at all. So this could be clad in anything. So it could be clad in brick, it could be clad in stone, it could have a render. So here's another example, stone and weatherboarding. So, you know, you've got your structural frame, you've got your insulation layer, and then you've got your cladding. So you can have all sorts of different things going on there. Johanna said, can I talk about some commercial buildings? So this is one that I made. It's for Jordan cereal. Do you have Jordan cereal here? It's like a breakfast cereal. And, you know, cereal manufacturers make a fortune because basically they've got oats and they're making a 2,000% markup, you know. So they wanted a building that was multi-purpose building. So they wanted a building that they could have a shop in, a cafe, and also a conference centre. So we built them this oak frame, and it's clad with different materials. It's quite contemporary. This is inside the cafe. There should be a post here and here. And there is further up the building, but the architect didn't want a post. So we had to take the post out and put a piece of steel. So we put a steel I-beam in across here because it's 12 metres span and it's got a whole load of stuff above it. And we've just clad it in some oak. But we've left gaps so you can actually see that it's a steel beam. We've not tried to hide the fact that it's a steel beam. We've got these sort of fancy scarf joints going on up here. Fairly straight braces to go, but also some curved stuff. This is their welcome. This is their boxes of cereal here that they're selling. This is the outside. Like I said, it's quite a contemporary sort of feel to it. What's interesting from our point of view is the glazing, because the glazing in this case is done directly onto the oak frame. It's not done in a SIP panel or anything like that. The glass is in the oak frame. And we know that the oak frame is going to shrink. So we have to detail for that. So what we do is, if this is the green oak frame here, we put a stable counterbatten on, and we have a dry oak cover strip. And then the glass is sandwiched with these little rubber pockets. And basically the glass is clamped onto the frame. So it's not actually fixed in any way, it's just clamped onto the frame. And when this shrinks on the inside, it's got nothing to do with the outside. The outside remains stable and the whole system remains waterproof. So you can see all of this is glazed in this way.
What material is the inside?
Okay, so it can be anything. We tend to use kiln-dried cedar, because it's quite stable, but you could use, I would say, softwood. I get told off for it, but yeah, so you could use anything, because we call oak, and we have oak in England, and then anything else is softwood. And I was talking to Catty about it. She thought it was really funny. I was calling everything softwood. And this is upstairs. Those steel beams are below that, so you can see why they need some steel beams. And this is like their conference centre or whatever, like that. But some big old spans, a big balcony outside. There again, they have the same sort of glazing detail going on there. This is the outside across the water. Nighttime shot. Right, so this is an interesting bunch of characters. This lot here are all my apprentices, past, present, and future. So, and really, they are an important part of my world and our world, because without these guys, we can't keep the skills alive, and we can't build these amazing stuff, and, we need to have the training in place. So, Aj here is in his 40s, Liam in his 30s, Sam is late 20s, Will is early 20s, Digby is 19, and Gabriel is 16. And Gabriel is the one making the pegs at the moment. And this is out the back of our workshop, out in the countryside. And I have had a couple of others. There was Ash there, and Bill there, and one's in Australia and the other's in France. But they all still work for me, and it's great. Liam is the interesting one to talk about now, because he came to me when he was 16. Most of my apprentices come when they're quite young. And his parents came into my office and said, Rupert, I want Liam to have a carpentry qualification. So there was no qualification in structural post and beam carpentry, which is what we're doing. There was qualifications in carpentry. So I packed him off to the local college one day a week, and he studied carpentry. So basically what he did was he fitted skirting board, he hung doors, and he fitted windows. So it absolutely had nothing to do with what he was doing at work, but he got a carpentry qualification. I was not very happy about this, so I talked to some of the other guys at the Guild, at the Carpenters Fellowship, and we thought it would be really good to develop our own qualifications. So we went to the construction board, the main UK construction board, and said, we want to develop a qualification in structural post and beam carpentry. Can you help us? And they did, but it took years, of course. But eventually we came up with a vocational qualification. So in the UK, all kids study subjects like maths and English to 16. And then after that, either you study vocational qualifications like engineering or hairdressing or being a chef, or you do more academic things like maths and science. So we developed a structural post and beam MVQ qualification. But that was only the first thing that we had to do, because we needed some examiners from our industry to be able to test the people that were doing the qualification. So then we had to get experienced carpenters to become examiners. And then we thought we needed an apprenticeship program so that they could be taught all the skills that they need to be able to pass the qualification. So we set up something called the Oak Frame Training Forum, which is part of the Carpenters Fellowship, and it has a training officer, and we made an apprenticeship program. And so now Gabriel here, he goes once a month, twice a month to a separate training school, and he's taught skills, and during a 2-year period he has to produce a portfolio of his work. And at the end of that 2-year period, one of these examiners I talked about earlier will come to our workshop and he'll inspect his work, he'll ask him questions, test his knowledge, probably come out to site, video him on site, making sure he's doing things safely, making sure he knows what he's doing. And if he reaches the required standard, he will get his MVQ. So the MVQ that he's doing is equivalent to A-levels, which is the sort of exams you take when you're 18. And we have another level of MVQ, which is MVQ level 3 now, which is like having a degree at a university. So that you would need to do, after you've done Gabriel's, you need to do at least 5 more years of timber framing to gain the knowledge to be able to do the higher MVQ. But they are the future. So, as I said, they are taught, you know, they're taught stuff like health and safety to start with. They're taught first aid. They're taught the theory of designing frames, making frames, and, you know, laying out frames, how to grade timber. They're not timber graders, but they're given the overview on grading timber so they know what to look out for and all of that sort of thing. They do practical courses like working at heights. Here they're working with ropes and harnesses, you know, because obviously we're working high up in big buildings using cranes and really dangerous. They're taught skills like repairing tools, sharpening tools, power tools, hand tools, all of that sort of stuff. And of course, this is the old MAFL 108 or whatever, stock and beast in our trade. They're taught to make frames and put frames up. I mean, they do that at work as well. But the thing is, because they're doing it off-site, they're getting one-to-one tuition, and they're with a group of other apprentices from other companies, and so they can all talk and join together. Okay, so I just got a little film about Frame. So Frame is like our convention in the UK that we have once a year. Here they're doing a bit of joint busting, so we bust joints and the information goes to a university, and then they use that information to improve engineering on frames and stuff because it's actual live stuff going on. So this little film is about Frame, and it's about our apprentices and what happens to them at Frame. So hopefully it should run. I might need to... We're at St Fagans in Cardiff, and this is our frame convention of the Carpenters Fellowship. It's been running since 2000, and it started after a meeting of carpenters at Westminster Arboretum, and we all decided that we wanted to join together and perhaps form a type of guild. And the Carpenters Fellowship was born at that meeting, and then we had our first frame convention, and it's been going every year since, usually at open-air museums such as this beautiful place at St Fagans. We've got a mixture of things going on here between fun activities and serious activities. We've got lectures going on all over the museum with engineers, architects and other professionals on a series of different subjects, from Russian staved churches to different types of joints. We've got an axe throwing competition, and we've also got a new competition this year which is the Moat Perrier team competition. And a Moat Perrier is a medieval siege machine, and we're throwing water-filled balloons at each other at different teams.
I've been very much involved for the last 10 years or so, but both myself and Rupert have been more involved in the training and standards side and developing qualifications. And I suppose that's the important work that we do. That's the more serious side of what we do, is actually developing qualifications. We've now got our NVQs level 2 and 3, we've got a full apprenticeship scheme, and we're working with different sorts of schemes in order to produce a very wide range of training and actually to get standards set in a way that they haven't ever been in this profession since the Middle Ages.
We're a group of apprentice oak framers, with a group being organised via the Carpenters Fellowship. It's the Oak Frame Training Forum, first batch of apprentices for, we were told on our first day, 200 years. So this is a specialist apprenticeship that's got funding from the usual apprentice routes.
This is the second big project we've done, yeah. We did another one in Bristol about 6-8 weeks ago, which was similar to this. It's interesting to see how the other companies work and how the other guys operate on their frames, and it's good to sort of share stories about companies and stuff, and I'd like to see how their companies work actually.
Well, I've met loads of people, and so loads of contacts and possibilities to ask the question, to see the other way of doing things, We had Pete Ayres and Henry Russell, and they've got two totally different approaches to carpentry, to framing, and it's nice to see that. Nice to pick the stuff you want to pick from it.
I think the main aim is for all the apprentices to get an understanding of a couple of new techniques we've come here to learn, like the roof geometry, like the laying out of this, and the hewing, which I don't think many people have done before.
I come here basically just to unwind, relax and enjoy the company of all of these people I see every year. It's a fantastic bunch of people, throwing axes, firing water bombs in a Perrier, having a beer, having a chat. It's great, you know. In a very big way, you know, we're connected. We're connected. All of these people are connected. Very diverse range of people, but there's something that connects us, and that something is something to do with that oak framing, the love of the craft, and that brings us together. And it's just a great weekend, and I come every year for that buzz.
So yes, Tim rounded it up nicely together by saying we're connected. And we're connected in the UK to you here in the Nordic countries and to the people in America, because it's our craft that we all share together that connects us. So I thought, you all come from cold countries, so I thought I'd put in this final picture of a house I built in the Alps in the snow to remind you all of home. Okay, thank you, Christians. That's me.